Welcome to Intermediate Statistics using SPSS 2nd edition. This video shows how to process the Mancova test. You can watch the entire video or use the time slider to navigate directly to any time point. The Mancova test is a hybrid of the MANOVA test and the ANCOVA test. Before proceeding, it's recommended that you first view the videos CH06 ANCOVA.mp4 and CH07 MANOVA.mp4. As the acronym suggests, the Mancova test blends the functions of the MANOVA test and the ANCOVA test together into a single test procedure. The Mancova test is like MANOVA. It computes the mean of the first dependent variable, pulse, for each of the three groups, the control group, pet therapy, and meditation, and conducts pairwise comparisons among the groups. Then it does the same for the second dependent variable, sense of well-being. Like the ANCOVA test, Mancova adjusts the results of the dependent variables based on the values of the identified covariate, stress, which is reasonably thought to influence pulse and well-being. In this example, we'll see that the Mancova results look similar to MANOVA, except the estimated results for pulse and well-being have been adjusted, controlling for the covariate, stress. The Mancova test has the same 5 pretest criteria as MANOVA: N quota, normality, moderate correlation, homogeneity of variance covariance, boxes M test, and homogeneity of variance, Levene's test. We'll check for the first 3 now. We'll see the results of the remaining 2 when we run the Mancova test. This example uses the dataset CH07 example 02 Mancova.sav. This dataset contains 4 variables. Group is a categorical variable containing 3 values: control, pet therapy, and meditation. Pulse is a continuous variable that contains the number of heartbeats per minute of each participant at the conclusion of the study. Well-being is a continuous variable that contains each participant's score on a well-being instrument at the conclusion of the study. And stress is a continuous covariate that contains each participant's score on a stress survey gathered at the beginning of the study. The first 3 pretest criteria, N quota, normality, and moderate correlation, focus on the 2 dependent variables, pulse and well-being. We'll begin by checking for the N quota. Click on Analyze, Descriptive Statistics, Frequencies. Move Group to Variables, and click OK. The frequency table indicates 30 participants per group, hence this criterion is satisfied. Next, we'll check for normality, starting with the control group, Group 1. Click Select Cases, click If Condition is Satisfied, click If. In the dialog box, enter Group equals 1. Click Continue, click OK. Now order the histograms with the normal curves for pulse and well-being. Click on Analyze, Descriptive Statistics, Frequencies. Click Reset, move pulse and well-being to Variables, click Charts, and select Histogram with normal curve. Click Continue, click OK, and it'll process. The histograms for pulse and well-being are normal for Group 1. Next, repeat the process for pet therapy, Group 2. Click Select Cases, click If. In the dialog box, enter Group equals 2. Click Continue, click OK. Now, order the histograms with normal curves for pulse and well-being. Click on Analyze, Descriptive Statistics, Frequencies. Click OK, and it'll process. The histograms for pulse and well-being are normal for Group 2. Now repeat the process once again for the meditation group. Group 3. Click on Select Cases. Click If. In the dialog box, enter Group equals 3. Click Continue. Click OK. Now, order histograms with normal curves for pulse and well-being. Click on Analyze, Descriptive Statistics, Frequencies. Click OK, and it'll process. The histograms for pulse and well-being are normal for Group 3. The normality criterion is satisfied. Before proceeding, reactivate all the records. Click on Filter $$ and press the Delete key. Now we'll check for moderate correlation between the two continuous outcome variables, pulse and well-being. Click on Analyze, Correlate, Bivariate. Move pulse and well-being to variables and click OK. The correlation between pulse and well-being is -0.621. Since this is between -0.9 and -0.3, this satisfies the criterion of moderate correlation. To run the Mancova test, click on Analyze, General Linear Model, Multivariate. Move pulse and well-being to dependent variables. Move group to fixed factors. And move stress to covariates. Click on Options. Move group to display means for. Check Compare Main Effects. Select Bonferroni. And check Homogeneity Tests. Click Continue. Click OK, and it'll process. To finalize the pretest checklist, we look to Box's test of equality of covariance matrices, which rendered a p-value of 0.901. Since this is greater than 0.001, this indicates that there is no statistically significant difference in the variance-covariance in this model. Hence, this pretest criterion is satisfied. Levine's test of equality of error variance shows a p-value of 0.819 for pulse and 0.426 for well-being. Since these p-values are greater than 0.05, this indicates that there is no statistically significant difference among the variances for the two dependent variables. Hence, this criterion is satisfied. Proceeding with the results of the Mancova test, the estimates table provides the means for each group adjusted per the covariate for pulse and well-being. These figures will be useful when documenting the results. Finally, we look to the pairwise comparisons table to determine which group performs statistically significantly different from which, controlling for the covariate, stress. Notice that the pairwise comparisons table essentially resembles two ANOVA multiple comparisons tables, wherein the top half of the table shows the pairwise comparisons for pulse, and the bottom half shows a separate set of comparisons for well-being. To identify which groups outperform which for each of the variables, identify the pairs of groups that have a p-value that's less than or equal to 0.05. This concludes this video.